Okay, number one, the amount of hand sanitizer dispensed from a machine at a healthcare facility is normally distributed with a mean of zero point 0.9 ounces and a standard deviation of zero point 0.1 ounces. What proportion of the time will it dispense less than zero point 0.8 ounces? Well, how am I going to figure that out? Let's see. Express it as a proportion, a percentage, whatever it is, as a decimal fraction. For 50%, try and use 0.50. Okay, so I'm going to draw that. I think that you're crazy not to sketch this out, because sketching it out will help you avoid problems. Okay, help you keep you from making kind of silly mistakes that you otherwise could avoid. Okay, let's see if I got one more copy of this. Oops, no, I don't. Okay, let me go back here. I'll tell you what, let me close this, and I'm going to open it again. Open, I don't think I saved it, so, oh, good. Okay, so in this particular case, I said that this is population, right? We mentioned that it was a population. Okay, so the mean is 0.9, right? And the standard deviation of the population is 0.1. And the question was, what percentage was below 0.8? Well, that means 0.9. Standard deviation for this would be 0.8. This would be zero point 0.7. This would be 1.0. This would be 1.1. So this is one standard deviation over here, right? Below the mean. I know this is using empirical formula. This is 68%. So I got to kind of figure out what is in this area here. You remember this is 34. So I'll leave that up to you to figure out what that is. Okay, but that's what I would expect with number in that particular problem. Very simple, right? But it's up to you to figure out what the exact numbers are. Let me just check, see if I got questions here. Um, I would round only at the last moment, and uh, 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 if you really don't have to round if you don't want to. Like 98.79%, that's okay, or 0.9879. Why bother around? You might as well write that number down. If you're doing a calculation in Excel and it comes out to be 28.97496 and it goes on for like 12 digits and stuff like that, then I can understand rounding that. I think a digit or two past the decimal place would probably be appropriate. The real answer is, what about significant? How many significant digits do you really have from what we gave you as information? And we'll talk about that as the semester goes on. It's kind of a little bit of a more complicated issue than really than it looks at first glance. But at any rate, make a reasonable judgment about it, and I won't take points out or for it. Okay, so but however, one thing you should always do: don't round until all the calculations are done. And then if you got a round, just round your answer. Okay? Because if you round before that, you have a good shot at having an error blow up on you. For instance, if the answer was 1.1, right? And I told you to square that number, right? Oh, well, and you rounded it to 1 and then squared the number. The square of 1 is 1. The square of 1.1 is 1.21. You'd be off by 21% if you rounded before you before you did that last operation, right? So try not to round until the very last calculation. Okay, so now where was I here? No, where am I? I'm trying to find that homework disappeared. Here it is. Okay, what's the percentage of the time it will dispense more than 1.1 ounces? Okay, percentage time more than 1.1 ounces. Well, this is 1.1 ounces here, right? The percentage of the time it will dispense more than 1.1. Well, that's two standard deviations. We know minus two standard deviations to plus two standard deviations. This represents 95% of the distribution. So this area combined with this area, which are the same because they're symmetrical, would add up to 5. So you get your own opportunity to figure out what's in there. Okay. What percentage of time will it dispense less than 0.7 or more than 1.1? Okay, well, You got this area is less than 1 point. So we just figured these. We just figured these two values out, right? Less than this value or more than this value. You would figure out what those areas are and add them together, right? Makes sense. Okay, let me put this back up again. Okay, come on. Okay, that's ow. Okay, I'm trying to get this to scroll up, but it's not cooperating. Question 3, question 4. Oh, I'm sorry. I popped that up again. That's not cooperating with me. Well, let me scroll. Man, I don't see it there. Do I see scroll by? Yeah, I do. Okay, let me scroll this up a bit and go back and look at it again. Question 4. Podiatrists collected data regarding men's shoe sizes and found that the distribution of sizes exactly fits a normal curve. The mean shoe size is 11, and the standard deviation is 1.5. What's the probability that a randomly chosen individual will have a shoe size smaller than 9? Well, the mean is, again, this is a population. We haven't, when we started on this homework, we hadn't discussed sample distributions and standard error yet. So we know that's not going to come up in this homework at all. Mean shoe size is 11. What's the probability he'll be smaller than 9? Well, this one we can't use the empirical formula for, can we? Because the standard deviation is 1.5, and this is two smaller than the standard shoe size. So 9 minus 11 is minus 2 divided by 1.5. Minus 2 and 1.5 is negative 1.33, whatever. But negative 1.33, that's as good as our table would do. We can go to our table and look up what that z-score is, and then calculate the error below that point. Okay. 5, what's the probability a randomly chosen individual has shoe size greater than 12? Well, 12 minus 1 is 1 greater than the mean, divided by the standard deviation, which is 1.5, would be 1 over 1.5, which is about 2/3 or 0.67. You can go to your table, find the area below that, right? But that's the area below 12. It's asking you for the area above 12. So you'd probably have to subtract that from 1 or from 100%. What's the probability of randomly chosen individual with shoe size between 9 and 12? And basically what you're going to do there is go back and combine the information that you got there. Now, a few people got this one wrong because they didn't read it very carefully, or the type was so small, they didn't really get it. What is the area of the standard normal distribution represented by the shaded area below? Negative 1.88 standard deviation, right? This is the standard normal distribution. This isn't just the mean is 0, and this is like a z-score, right? Same as a z-score. So it's a standard normal distribution. What's the area that's represented in there? Well, let's see, it's minus 1.88 and plus 1.88. Okay, if we were going to use our table just like we did before, our table always gives us an area to the left of a z-score. So if I went to it and looked up 1.88, it would give me an area, I'm going to guess, say 92% or 0.92. And that would be the area to the left of this 1.88. Okay, well then we don't want the whole thing, we want the shaded one. So I would go over here, take this minus 1.88, and I would find the area there and subtract it from the area that was to the left of 1.88, and that would leave me with the shaded portion of this. Okay, you got to use a little bit of trickery in doing this. Okay, the following table shows the political affiliation of voters in the city and their positions on stronger gun control. Given a person is a Democrat, what's the probability he opposes stronger gun control? I changed this a couple of times. So if you people noticed that you got a wrong answer over there, if you were among the first 1 or 2 people last week that put this up, let me know and I'll go back and you should go back and check it again, or just let me know if you think you got it wrong, and I'll go back and take another look at it. And basically I'll give everybody a pass on it if you did it before tonight. Okay, given a person is a Democrat, what's the probability he opposes gun control? This is a conditional probability, right? I'm going to change it a little bit. I'm going to say given that a person is a Republican, What's the probability that he opposes stronger gun control? Well, we're only looking, the first condition has to be satisfied. We're only looking at Republicans, right? Well, Republicans represent what part of the total population? 0.11 and 0.27. So they represent 38% of the population. Of that, 27% of the Republican part of the population says that they oppose gun control. So, given that you're a Republican, the proportion of Republicans that oppose gun control is 0.27 divided by 0.11 plus 0.27 or 0.38. 0.27 divided by 0.38, which I guess is around, I guess 60 or 70%. Okay, that's the way you would solve this and then choose the right value here, except that you're doing it for Democrats, not for Republicans, because that's the conditional probability that we're actually dealing with on that particular problem. Yeah, I hope I'm not giving away too much of the ranch here. Okay, let me see. I think I skipped. I think I went too far there. Let me get another look here. Okay, yeah, here we go. It's 9. The Affordable Care Act has brought health insurance within the reach of many more people. However, some left behind. Current estimates suggest that 12% of people are still uninsured. I made these numbers up, so don't quote them. Suppose that 10 people were randomly and independently sampled. What is the probability that exactly one of them is uninsured? Anybody want to tell me what kind of distribution is that? Somebody tell me what kind of problem it is. What kind of distribution am I dealing with there? Binomial, exactly. And the best way I know of to solve a binomial distribution problem is to open up Excel, which I'm going to do right here. And I'm going to blow it up so I can see the boxes. And I'm going to make it a little smaller so it doesn't take up the whole screen. Okay, so I can see this problem. And what's the probability? Oops, let me escape there. So I can't make this go right. There we go. What's the probability that exactly one of these people are insured, given that the probability of being is uninsured, probability uninsured is 12%. So I'm going to type in equals binom dist, parentheses. Oh, okay, now it's asking me to put in these parameters. The number of successes. Well, the number of successes is the number of people that I find that are uninsured out of those 10. 1, comma, the number of trials. Number of trials is 10 people. I'm sampling 10 people. And the probability of success is 0.1. Probability that you're going to get somebody in that, that is uninsured is I'm sure 0.12 is 12%. Comma, now I have to make a choice, cumulative or not cumulative. Since it's only asking me to tell it the probability for exactly one person out of 10, right? Then I only want that probability. So cumulative is going to be false. Just give me that one probability. Had I said, what's the probability that one or fewer people were uninsured? Well, then that would be satisfied not just by one person out of 10 being uninsured, but no people out of 10 being uninsured. So then I would have put in true, and it would have given me the probability for either 1 out of 10 being uninsured or added to the probability of 0 out of 10 being insured. It would be a bigger number. I'm not going to solve it there. I'm going to let you guys go ahead and figure out what that number is going to be. Okay, what's the probability of 3 or more of them? What's the probability that exactly 2 or fewer are uninsured? I'm going to change that up a little bit. I'm going to say, what's the probability that 4 or fewer are uninsured? Equals binom dist, parentheses, 4 or fewer. So successes is 4, 4 or fewer, 10 trials, comma, 0.12, comma, and I'm going to say true because I want the probability for 4 or fewer, everything below 4. And I get 99.6% is the probability, or 0.996 is the probability. Next question asks, what's the probability of 3 or more? I'm actually rephrasing this. So this is for 4 or fewer, right? That's why when I click in here, you see binom dist 410.12 true. That tells you the probability that if you have selected 10 people, 4, 3, 2, 1, or 0 of them would be uninsured. Okay, now if I had asked you, what's the probability that 5 or more were uninsured? Right? Well, let's think about this. Probability that 4 or fewer are uninsured is 99%. The probability that 5 or more are uninsured is just what's left, right? Because 4 or fewer, 5 or more is just what's left. Because if we added up all the possibilities, it'd be equal to 1. So all you have to do here, one, is say equals this minus 1. 1 minus this. 1 minus this value here. Okay. Another way you could have done this, if somebody had asked you, what's the probability that 2 or more were uninsured? Well, you can't do 2 and up, but you can do going down. 2 or more, what you would do is you say equals binom dist, right? For 2 or more, you would say 1, comma, 10, comma, 0.12, comma, true, right? That's for 1 and 0. So 2 or more would just simply be equal to 1 minus this. If I asked you, what's the probability that, let's see, more than 2, what's the probability that more than 2 people would be uninsured? That's not including 2. I asked you, what's the probability more than 2 would be uninsured? Well, in that case, I would do equals binom dist, parentheses, and they would say more than 2. It's not, they don't want to include 2 when it says more than 2. So I'm going to say 2 is going to be in the lower part. 2, comma, 10, comma, 0.12, comma, true. And that's the percentage I get. And I'm going to say the likelihood of more than 2 is going to be everything that's left after 2 or less. So that's going to be equal to 1 minus that. The trickiest part of this is that it's kind of a word problem, and you have to be careful and understand that these, you have to very carefully parse what they're looking for. Okay, so let me go back to this. I'm going to continue here. So they're insured. So yeah, you actually have some there you have to work on your own. Okay, the following results. The following are results of data collection on the result of data collection on mammograms detecting breast cancer. I'm hoping you can see this. It's very light on my computer, but it should be familiar to you because I think almost all of you at least tried the homework so far, at least if not submitted, at least tried it. So what's the probability? How many tests were false? Is there a part of this that I'm missing here? Let me just scroll up a little bit so I make sure I don't miss something. Oh no, it's just the introduction. How many tests were false positives? Okay, let's see, positives. This is a true positive, right? Now remember, a false positive has to be a positive. It's still a positive, right? So this 45 is not a false positive, right? That's actually a false negative because the test was negative and it was wrong. The person had the disease. So I'll leave it up to you to figure out which one is a false positive. Your problem number 11, you're confused by? Let me go back to problem number 11. I got 2 people that are concerned about problem number 11. Okay, what's the probability that 3 or more of them is uninsured? I'm going to ask you, Rebecca, or one of you guys that had a problem, type in equals binom dist, and what would you say would you start with for solving what's the probability of three or more is uninsured? Which binom dist, how would you type in that binom dist formula? Okay, remember, since you're doing more, you're looking for the area above, the probability above a certain number, you're going to wind up subtracting something from one, right? But what would you start with as a binom dist? Binom dist, comma, parentheses, 3. Rebecca says 3. Jennifer says 2. Okay. Now, Rebecca, think about this. If you put a 3 in there, your 3 is going to be included in the bottom part, right? So you need to put a 2 in there instead of a 3 because you want your 3, because it says 3 or more, conclude that 3. Now, Joni did the same thing, right? If you solve that, then you're getting the probability for 3, 2, 1, and 0. And then if you subtract it from 1, you'll be left with the probability for 4, 5, 6, 7, 8, 9. But it's not asking for the probability to have 4 or more. It's asking for the probability for 3 or more. So you want in the lower part of your probability, the part you're going to subtract from 1, you want 2 in there. You don't want 3, right? Because if you have 3 in there, then you're no longer, when you subtract from 1, you're not finding the probability of 3 or more. You're finding the probability of 4 or more because the probability of 3 was included in your equation, which goes to the left, down. Does that make sense to you, Joni, Rebecca, and Jennifer? You guys get that? Okay, got at least one person that thinks they got it. How about another one? Joni, you okay with that? Somewhat okay. That's enough for now, right? We can hit this again tomorrow night. Okay, we got an hour and a half tomorrow night. We can play around with this again. Okay, so let me move on. It's getting kind of late. Let's see. I think the next. What is the sensitivity of this screening test? I actually express it as decimal probability rather than a percentage. What's the sensitivity? Anybody want to tell me? I'm gonna go ahead and let you guys don't work the fraction out. So leave that to everybody else. But what numbers would you use to figure out what's the sensitivity of this test? What does the sensitivity of this test represent? It represents how good it is at identifying people that have the disease, right? Those with the disease. So the sensitivity would be, let's see, 177 people have the disease. How often did it get it right? It got it right 132 times, right? Well, we got true positives, right? And we got the total number of positives. Exactly, Marcy. So the percentage of time that it got it right, the sensitivity is 132 over the total number of people that had the disease, 177. It missed 45% of the people. Now, had it been a perfect test, you would have gotten 177 positives for the people with the disease, no negatives for the people with the disease, and for a total of 177. That would have been a perfect test with 100% sensitivity, right? 177 divided by 177. Okay, but that's not the case. Usually, almost never is the case, although we have some tests that get pretty close. What's the sensitivity? What's the specificity of this test? That gets a little bit more complicated. Okay, specificity is how good is it at identifying people that don't have the disease. Okay, well, let's see how good it did that, how often it got that right. There were 64,000 people that didn't have the disease. It got it right 63,000 times. So the specificity is 63,000 divided by 64,000, right? That's how often it got it right. Actually, if the numbers are a little bit more complicated, but it got it right like 99% of the time, right? It got it wrong a very small percentage of the time. So it's 63%, 63,000 over 64,000 is how good it was at getting it right. Okay, now what's the positive predictive value of this test? Positive predictive value of this test. Anybody want to hazard a guess at it? That is, it's the true positives over all the positives. How many people tested positive? A total of 1,100 people tested positive, but only 132 of those people that tested positive have the disease. So if you're among those 1,100 people that tested positive, right? Well, the probability you actually have the disease is only 132 over 1,100, or roughly about 10 or 11%. So that would be your positive predictive value. Somebody give me the negative predictive value. What do you think the negative predictive value would be? That's how good you are. That's if you test negative, right? How many people tested negative? Okay, looks like 63,695 people tested negative. Out of those 695 people, what's the probability that you're really negative? Well, 63,000 people out of those 63,650 out of 63,695 people who tested negative, right, had the correct diagnosis. They don't have the disease, they got the correct diagnosis. The negative predictive value is no disease and test negative over the total number of people that test negative, right? Which is really high, like Gerald said, 99.9% or something like that. Okay, that's probably the value. I think the last couple of things that I asked you was short essay questions. Okay, okay, what's the prevalence of breast cancer in this population? Well, that's kind of a little bit of a curveball, right? Because it got away from this idea of what's in that test, what's in that diagnostic test, but you actually can kind of deduce it from this table, right? How big is this sample of this population? Sample of this population is 64,000 people. How many people in this population actually have the disease? Well, 177. So the prevalence of this condition of breast cancer in this population at this moment, right? The prevalence in right at this moment is 177 people out of 64,000. That's not a very prevalent disease. It's only about, I guess, uh, 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 what is that? 1 in 1,000 or something like that. 1 in 100 or something like that, or 1 in 64. No, 1 in 600. I guess 2 in 600. 1 in 300. You can figure out the actual fraction for yourselves. And finally, let's take a look at these two questions I asked. What circumstances contribute to the rather low positive predictive value for our breast cancer screening? Now, if you just said, well, the prevalence is very low, and that makes you have a low positive predictive value. I gave you probably 8 points out of 10 points for that because you're basically stating the obvious. How does the low prevalence do that? What is there about having a low prevalence that makes the positive predictive value so bad for diseases that are not common, that have a low prevalence? And if you look at this, you say to yourself, gee, there's an awful lot of people that we're testing that don't have the disease. So we're testing a lot of people that don't have the disease. That gives us a lot of opportunity to have false positives, right? So there aren't many people that have the disease. So we're always going to have a low number of true positives. So this number tends to blow up, and this number tends to stay small. So I was hoping some feedback, on in a form that would tell me that you understood that that's how the prevalence actually affected all this. Now, this one I asked about what's a clinical trial and so on and so forth. What's the benefits of randomly assigning the subjects to treatment? And we know that that's going to remove some of the biases. In other words, presumably, if they're smokers, only each group will have the same percentage of smokers and stuff like that. You won't have one group that has all the smokers and so on and so forth. I said maximum 100 words. It would be nice if you gave me a little bit more than just well, it takes care of like confounders, right? Just it would be nice if you gave me a little bit more of an explanation than that. Okay. Otherwise, I think most of you guys had a pretty good idea of what was going on with this assignment. I'll give you until after the test. I'll give you a day after the test to complete the assignment if you haven't done it already. But you really should work on it because some of this stuff is going to be on the exam. Okay, the binomial distribution, the the uh, 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 diagnostic test, so on and so on and so. And besides the stuff that I talked about, that's likely to turn up from assignment 1 and 1A. Okay, so hopefully that'll give you kind of a picture of what's going on. We'll tune in tomorrow for about an hour, a little bit more than an hour, and we'll go over some of the questions. If you, some questions that you might have, if you have questions, email them to me. If you have a specific area that you're uncomfortable with, email it to me. So, and remember, put PH750 in the subject of the email so it doesn't fly under the radar with all the emails.